Shots fired by Joseph. All right, graphing linear functions. Okay, so linear functions. What does linear mean?
Straight line.
A straight line, right? So this is going to be, we're getting into chapter 3, straight lines. Straight lines are a part of math.
We love math.
Okay, lines go vertical, which are straight up and down. They go horizontal, which is flat, going right and left. They go diagonal, where they rise to the right, or they go diagonal where they fall to the right. So they can, there's all kinds of things a line can do. Okay, so concept of a function. All right, so we're going to be doing input and output. Okay, so if we're going to go in and we have a rule that's going minus 80. So if I put 130 in, I subtract 80 from it, I get to 50. Is that okay?
Yeah.
If I put 290 in, I'm going to subtract 80 from it and get 210.
Oh, yeah.
Okay, so what number goes here? 100? 100? Everyone see that?
Yeah.
So if I put 100 in and I subtract 80 from it, I get to 20. What about 270?
350.
How much?
350.
350. If I plug 350 in and I subtract 80, I get 270 out.
420. 420. I'm a 420.
Shut up, bro. 420? 420, subtract 80. Sweet. That's exactly it. So a lot of times linear equations work where you are putting something in and you're getting something out. If we had plotted these on the x and the y axis, where I had the points 130, 50, 290, 210, 100, 20, 350, 270, and 420, 340, they would form a straight, or be points that would line up into a straight line. Yeah.
Didn't we do this in like third grade?
Probably, but we want to take this.
Here for third grade, so I've never done.
Well, aren't you still in third grade?
So I want to pull up our calculator. It should be coming. Okay, Smart View calculator, sweet. All right. So
Parabola.
How does that work?
all right. So what I'm going to do is I want to clear out the information up here. Okay. So let's clear all of our stuff. All right. Ready? So what I'm going to do is I'm going to go into stats. So with me, I'm going to edit. And list 1 is going to be our input. So going down list 1, I'm going to go 130, 290, 100. What? What'd I do?
I don't know.
You keep saying something. 350, enter, and 420, enter. And then list 2 is going to be the output, right? And guys, girls, you do not need to know how to do this at this point. I'm just doing this for representation. 50, 210, 20, 270, 340. Okay, did I plug those in correctly?
Yeah.
So 130, 50, 130, 50. I know it's a little small, but we're going to see what's going to happen in a sec. Okay, 290, 210, 100, 20, 350, 270, 420, 340. Still with me?
Yeah.
Okay. All right. Let's change the view a little bit.
Wow, that's so cool.
This is a really fancy calculator. I wish I got this instead of mine. This game is like the same exact one.
I'd rather
Well,
have
I
it on
know
the
it's the
computer
same
for
exact
free.
one, but I could get it on the computer.
That's fine. All right. So I'm gonna go. What?
There's a teacher.
Hey! She's right next door, I believe. But you're always welcome to be in here. All right. So I need to turn on my plots. So I'm going to turn on my stat plot.
Wait, are you gonna show us how to do this?
Okay. I will. And again, you don't need to be pro at this. So I'm turning this on. I'm going to have it as broken data. I'm going to use list 1 and list 2. Okay?
Mm-hmm.
That's L1, L2. And I'm going to use the square mark, and we're going to make them blue. Okay? If I go to zoom and I go to stat, which is number 9, that's what the data looks like. I've adjusted the window on this calculator to work with this. And take a look. If I were to draw a straight line, it'd go right through these points.
Wait, so if there's an input and an output that's exactly the same with the same proportions, it comes out to the same straight line?
Well, not everything that I should do as an input and output will form a straight line, but as far as linear equations go, it will. There's definitely input outputs that we can change that won't give us a straight line. But does everyone feel comfortable with me saying that this appears to be a straight line? If I were to connect the dots, does everyone feel okay with that?
Yes.
Okay. What?
Never mind.
Okay. So, other things that this calculator will do are these types of things. So if I go stat,
Are we gonna have to like memorize?
I am not. Again, you do not need to know this.
Well, not like right now, but like by the end of the year.
You will get there. So if I do this with the calculator, I want to do the linear regression because it's a straight line. That right there, y equals 1x minus 80.
Wait, what?
Okay? So notice it says
Oh.
a equals 1, b equals negative 80. So y equals ax plus b. So if I plug a in for 1, or 1 in for a, and negative 80 in for b, okay? So I'm going to plug this in just like this. Ready? Negative 1. So negative 1x. And what was the number?
1
Minus 80.
negative.
Minus 80 or plus negative 80, right?
Yeah. Why is that? Where's the 1?
Is negative x and negative 1x the same thing? Does that make sense? And then plus negative 80 is the same thing as minus 80, right? Watch this. Ready?
Yep. Oh.
Oh. I'm so
It's coming.
confused.
It's coming.
Skipping a line.
What's coming?
It's gonna graph.
You should be getting a line there eventually.
That is the line.
Y equals, we got it.
Wait, try 1x.
Or the
Should be on. Enter. Graph. Oh, I went back to blue. Where's it at?
Where's the? That is the line. Wait, why do we? Where's the?
No, there should be a line in
Yeah, there should be a straight line coming, but it's,
It's a little slow.
yeah, we don't hold it against it.
No, I
Go
want
to-
that was gonna be like the coolest thing I've ever seen.
Come on, Smart View. TI-84, Smart View. Alright, y equals, what was it, negative x?
minus 80.
Minus 80?
Or plus negative.
This better
Or
work.
plus
Whoa,
negative?
that's slow.
Graph.
This better work.
Better.
No, give it
Okay,
time.
we're not going to be, hang on. So one thing I want to do is, I'm going to change my window. I'm going to negative, or 68 to 452. Window 68 to, what was the other one?
452.
452. Okay, and then the Y window, negative 34 to about 400. So negative 34.
94.4.
Negative 34 to 400.
394.4.
Okay, but we're being rough. Okay. Graph. Graph.
Why doesn't it graph?
Where's it at? I don't know where it went. Oh my gosh, it was so totally supposed to be so cool.
Why is it being like that?
I don't know. It's being difficult with me right now.
Well, that was supposed to be the highlight.
Now your day's ruined now. Anyhow, I tried to make it special. Of course, I goofed it up. Remind me, I gotta unmark you for being absent, but I'll get you in a minute. Okay, and this is yours. And you have a test you need to make up with me. Okay. Yeah, I'll be in here. Cool. Thank you. Let's move on forward. So input, output. So we did get the boxes to show up. It did appear to be a straight line. I apologize that the thing that was supposed to draw the straight line goofed up on us. But we'll make it work next time. The computer sometimes gets a little goofy with things. So we have a relation and we have a function. Okay. All relations are functions. Not all all functions are relations. Not all relations are functions. Okay. A relation is this. If I said x comma y. Okay. Or 3 comma 7 or 8 comma 10. Okay, ordered pairs. Okay, a relation, you have a domain, which are your x values, and you have a range, which are your y values. Okay, and in order for your relation to be a function, oh, thank you. In order for your relation to be a function, the range, which is what value? The y values don't repeat. Okay? So, if I had, let's say this, 4 comma 7, 5 comma 8, 10 comma 12. Okay, first off, this is a relation because we have x and y values, correct? This relation is a function because none of my y values repeat. I have a y value of a 7, I have a y value of an 8, and I have a y value of a 12. Okay? The x values are 4, 5, and 10 in this case. So, as far as the relation goes, if the y value repeats even once, even if you had like 10,000 numbers and one of the y values repeated, it's not a function. Okay?
What? I don't get it.
I think you just answer sometimes because you want to be heard.
No,
I have 10,000 xy values. You with me?
no, like I don't get why, like how the rate function can't be a relation.
Okay, what is my rule so far?
Range shouldn't repeat.
So which value can't repeat? Okay, so if you had a whole string of 10,000 xy values, all ordered pairs. With me still? So 3 comma 4, 10 comma 9. Okay, that would be a function as long as none of the y values repeated even once. Okay?
Is it only y?
Only y. Only y. The x values can repeat all day long, and it's still a function. Okay, so we're just getting into some terminology. So our relation is like ordered pairs, x and y values. Okay? Anytime you have x and y values, you have a relation. When you take a look at them, if the x's are repeating, great, you still have a function. If any of the y's repeat even one time, even doesn't matter if you have millions and millions of ordered pairs. If one of those ordered pairs has the same y value, the relation that you have is no longer a function. Yeah.
So if there's like 5 numbers, 4, 7, 5, 8, 10, 12, 10, 11, and like 10, 13, that would be good.
That would fall into a function because the x's are repeating, that's okay.
But if there's 2 10, 13s, or if there's like a 5, 13 and a 10, 13, that would not be good.
So if we had 100 comma 8. Okay, the 100 is not repeating at all,
The 2
but the
8s.
8s, this means that we no longer have a function. We still have a relation, but we don't have a function. Ram,
If it isn't a function, what is it?
again, I'm just trying to give you a brief description. We're going to get further. Yeah.
If a negative number is the same as like a positive number.
Oh, okay. So if I had 5, negative 7, those are not the same number. They're two different numbers. So one can be positive, one can be negative. Okay?
So that would work.
That would work as a function, yes. Okay. So one thing we're going to start trying and we're going to learn is something called the vertical line test. Okay? If we're looking at a picture, we have something graphed. Okay? Whether we graphed it by hand and connected the dots or our calculator actually worked, okay? You create something called the vertical line test. Okay? If you take a vertical line, any vertical line along your screen. So let's say I had an XY graph and I had plotted something that would look like this, okay, which is a graph, okay? I don't know what kind of graph it is, but it's a graph. If I take a vertical line and draw it anywhere here, look at all these vertical lines. Let's pretend all of them are straight up and down. If the vertical line only crosses the line at most one time, your function, your relation is a function. Okay, so let me repeat that. If any vertical line drawn crosses your graph only one time, any vertical line, no matter whether it's all the way that way, all the way this way, if you can draw infinite vertical lines, if those vertical lines only touch the graph one time or cross the graph one time, you have a function.
Wait, touch it. Why?
See how it crosses? See how the black crosses the red?
Yeah.
That's a one-time touch.
How is
So a function that definitely wouldn't work is a shape that you all know. Let's go with Mr. Circle. Okay? So if you have a circle and I draw a vertical line through it, notice it touches twice. So a circle is not a function. Is a circle a relation though?
No.
Yes. We have all relations because we have XY plots, right?
But it didn't touch one time.
But a relation happens as long as I have XY points. X comma Y. Like, I don't know what the XY values are, but if I were to find right here, this would be an XY point. That totally works. If I were to say, well, what about this right here? That's an XY value. There's a point there.
So it can only touch.
How? Okay, a point. Do you understand that you represent a point like this? So you're with me there. So this circle has an infinite amount of points all the way around it. There's infinite XY values. There's infinite XY values all the way through on this. Yeah.
Wait, so a function is like any open shape?
A function is just a special relation in which the Y values don't repeat.
But could there like be a closed shape that would work as a function?
Not that I can think of right now. Okay? So domain talks about the X values. The range talks about the Y values. So, smiley face, comma, frowny face. Which one is the domain in that picture? Smiley face. Why? It's the X value. If the smiley face is the domain, then what is the range? The frowny face. Why is the frowny face the range? It's the Y. Okay, so the domain are the X values, the range are the Y values. Okay, I can have a whole bunch of ordered pairs. 1, 2. Okay, what's the domain of what we have represented? Say it.
1, 3, 5, 7, 9.
1, 3, 5, 7, 9. Perfect. What is the range?
2, 4, 6, 8, 10.
2, 4, 6, 8, 10. Is this a relation that we have up on the board? Yes, I have points. I have X, Y values, so we have a relation. Is this relation a function? Yes. How do we know? Y values do not repeat. I have 2, 4, 6, 8, 10. Those are different numbers. They don't repeat. This relation is a function as it sits. Yeah. We good so far?
Yeah.
All right. For each of the following examples, use the given relation values to fill in order in the other representations, identify whether or not the relation is a function and state why. Okay? So we have some points here. Do we agree? What point does this appear to be?
Zero, zero,
Oh.
1, 0. Agree? And then what is this one?
3, 2.
3, comma 2. What is this one?
2, 1.
Negative 2, what?
1.
1.
And what does this one appear to be?
That would be
Negative
negative 4,
4, 3.
negative 4, 3.
Negative 4, 3. And then what does this one appear to be?
Negative 2.
Negative 2. Okay? So the domain appears to be 3, 1, negative 2, negative 2.
Oh, so we have to list all of them.
Wait. I missed one.
0.
Negative 4, okay.
Wait, so you have to
Zero.
list all the domains.
Did I list them?
Negative 4.
3, 1, negative. So hang on. Did I get all those? Negative 4, negative 2, 3, 1, negative 2. Range. 3, 1, 2, 0, negative 2.
It's a function.
Okay, it was really hard to write.
Okay. Now, does anyone see an error?
Yes.
Why?
Oh,
Because they repeat negative 2.
Okay, negative 2 is repeating here in the domain.
wait, but that's.
Let's see if you pick it up.
Oh!
What?
Is it that there's 2 negative 2s and
What?
there's
What is not going to pass here?
Straight line.
The straight
Oh, it's
line.
one. Oh no. Oh,
That
no.
vertical line crossed twice.
Yes, it did. But the thing is,
Hang on. Does everyone agree? This crossed here, this crossed here.
yes.
Wait.
Hang on. Everyone agree?
I'm so confused.
Okay, everyone agree with the domain.
Yes.
Everyone agree with the range. She's back here now. That came for you earlier. Okay? So hang on. What happened? I just said the vertical line test, if it doesn't pass, means what? Hang on, we just go back. Was it here? No, it was here. Vertical line test. If the vertical line test touches one time, we're fine. If it touches twice, it's not a function.
Oh.
Okay? It's not a function. So let's go back to our graph. It touches twice, so it doesn't. Wait a minute.
Wait, it touches
Hang
one.
on. Wait a minute. Dyslexia works well with me today. Did I make an error in what I stated? The vertical line test determines if you have a function. Agree? So what is the repeater up here? What repeats up here?
The domain.
What repeats? Say it.
Negative 2.
Negative 2, which is part of our?
Domain.
Oh, shoot. Boy, you know, a lot of kids flip-flop that. Did I flip-flop it?
Yes, kind of. Yes, yes, you did.
Wait, Mr. Sir, can you go back to the graph?
Okay. What repeated on our graph?
The domain. not
The
range.
domain. Agree? Agree?
Yes.
Which is what? Oh. So here's the fun thing. I wanted to flip-flop it for a reason because there's so many kids that goof this up. What repeated on our graph?
Domain.
Which was part of what?
X.
The X, which is the domain. So if, what needs to change up here?
Everything.
What needs to change up here?
Domain
The
can.
range
What
or
should
the
this
domain?
change to?
Domain.
Domain.
That should change to domain,
Wait, why?
which are the X values.
But They're not allowed to repeat.
Hang on.
Why are you doing
Hang
that?
on. Watch. I'm telling you for a reason. So remember, we talked the vertical line test. Hang on. Shh. The vertical line test. Shh. The vertical line test. If you draw it on a picture, and your vertical line crosses your graph more than once, you don't have a function. So I said it backwards here accidentally. Oh, poor me.
I was trying to mind. Now I'm gonna think.
It is so often, it is so often flip-flopped. It doesn't matter which way I teach it. Students flip-flop it all the time. So I flip-flopped it on purpose. Okay? So, the domain, which is the what value? X value. By looking at our graph, our X value here repeats. We have the same X value there. Which we have the domain repeating, which means the vertical line test did not pass. So, is this a function?
No.
This is a no. Why?
Because
The what repeat?
domain.
Domain. Awesome.
Oh my.
Wait,
Okay.
Okay, hold on.
Okay.
Just-
So I did it on purpose that way because I can tell you, 21 years of teaching, no matter what I say, I get still half the class flip-flopping it.
Wait,
Which
so
half of the class is now going to get it right?
wait, that was part of your lesson.
Oh, isn't that beautiful?
Yeah,
you're
we're
not.
more confused.
Okay.
Honestly,
Well,
that's into our mind that it's the range that should
Whoa,
repeat.
chill out, Rob.
So,
Yeah.
domain, let's say, domain repeats, no function. Ready? Domain repeats, no function. Say it again.
Domain repeats, no
Louder.
Domain repeats no function.
I can't hear you.
Domain repeats no function.
We need to hear it on the football field.
Okay.
Louder.
Domain repeats.
Why is Rob the only one saying it?
Wait, what is it again?
Domain repeats, no function.
Mr. Sir, can I point something out?
What?
Can I go there?
No.
Okay. So do you see 32? Like the point 32.
Yes.
3, 2, right here.
Yeah, and then you see the one. Yeah, and then you see one. Yeah, that one.
Yes, I see it.
And then you see the one that's circled with green. The
This one,
-2,
-2, -2, yeah.
Doesn't that make a line?
Oh, it appears to be yes.
So
I like-
it touch 2 times.
Well, a straight line. Vertical line is our test.
Well, that wouldn't be a straight line. That wouldn't be a
It,
straight
well, it might. It appears that it might be, but I don't know. Yeah.
So it's not a function if both of them repeat. So if anything.
This is
in
the
range-
one. This is the one we are worried about. Domain repeats.
Wait.
Domain repeats.
No function.
Domain repeats.
Okay, I get that, but so now the range, if that repeats, it's still a function.
Yes.
I was trying to think. How
You're
I
okay.
could have-
What did we just say? Domain repeats, no function. It's there. Domain repeats.
So is this a false fact?
If the domain repeats, then it's a no
I
function.
did it on purpose.
So if X repeats.
How cool is that? Huh?
All
All right. All right. So, you could create a t-table off of our information. So our t-table would be -4, 3 in some order, but you're trying to keep everything 3, 2. Okay. 1, 0. -2, -2. And we had one more point I'm not seeing. Is that -2, 1? And then the ordered pairs from the t-table would be like this. What's confusing? I'm writing down points.
Why did you switch to domain?
I love it.
No, that's not good.
To mess with you.
No, you know what's great is because you're so worked up about it, you got it.
I don't have
You
it.
do.
He's trying.
Domain repeats?
No
No, I'm not saying it.
Why not?
Because it doesn't make sense.
It sure does.
No, it doesn't.
Domain repeats no function.
Why did you switch it with
Because he wanted to confuse you.
Why are you using a?
Okay, so again, no matter how I would have taught it, we still have at least half of the class would get it wrong. So I'm trying to undo.
Wait, you just taught us.
No, but why did I do that? So let me ask you this. Hang on.
Oh.
Your logical progression of events. Your logical progression of events. Teaching it, saying domain repeats, no function, starting out that way. It's now something that you're like, wait a minute. And there's half the class that will miss it over and over. Doesn't matter how many times I do it. So now if I flip-flopped it, now you have a page break that's taking place on this. So hopefully that'll be embedded that you get it.
But I don't get it.
I know.
Okay, domain repeats no function. What part of that? X repeats no function. X repeats no function. X repeats no function. I know. I'm taking that back away. Domain repeats no function. Domain repeats no function. That's it. So domain repeats no function. See now you're domain repeats.
Just don't
We
care
have
about
a
the
fun
range
little
anymore.
cheer. We could bring the cheerleader and the palm up here, and the palm could do a dance. The cheerleader could do it.
I'll make domain repeats no function.
Did I say anything about the range right now? Did I make a cutesy cheer about it? I flip-flopped them on purpose. Now, good.
They're worrying about
All right. Yes. What? I heard Mr. Stroop. Me.
So you could like remember it because like when you think about like if it's domain or range, you could like think like our first name was Mr. Upside is range and then he flip-flopped it to domain. And you could remember.
All right.
So you don't
Ready? Here we go. I'm going to go from the ordered pairs to the t-table. Still with me? Ordered pairs to the t-table. Negative 2, 5, 4, 3, 2, 5, 3, negative 1, 2, 6. Domain repeats. Does the domain repeat?
Yes.
It does. Function?
No.
No. Why? Domain repeats.
Can we write that for the difference?
Yes. No function. Alright? Domain repeats no function. Alright, we'll go up here. The domain.
So if you do the y, that's the range and the x is the domain.
There you go.
Alright. Because he just was trying to confuse you.
You guys are worrying about the very little things that don't matter.
Isn't that funny?
You already said earlier.
Alright. Let's plot our points. I tried to get those back in order. So negative 2, 5, negative 2, right? 2, 3, 4, 5. Is that right? 4, 3.
Two,
2, 5. Thank you. 2, 5. 3, negative 1. And 2. What's the last one? 2, negative 6. 2 positive 6. Oh, that's right up here. Vertical line test work?
No.
Where does it cross?
2 positive 6.
Right
2
here.
positive 6 and 2.
There's my vertical line, right? Touches both of those. Not a function.
Oh, that makes so much sense.
Woo!
Because it repeats on you too.
Good.
Yes.
Because the domain repeated. So there's no.
So that if the domain repeats, then is it?
What are we talking for?
FT got it.
Wait, I have a question.
Talk to me.
If the domain repeats, then is it a range? Wait, no. But if the domain doesn't repeat, is it? I don't know.
If a domain repeats, it's no function.
If it does not repeat, you have a function.
No, you said.
Then
If
you
the
have
domain does not repeat, you have a function. If the domain repeats, no function.
Then say it. Say domain repeats.
All right, ordered pairs. We got what? Negative 2, 4. What else? Negative 1, 1. What else? 0, 0. What else? 1, 1. What else? 2, 4. Agree? I went from my table to here?
It's way too small to draw.
Okay.
Yeah.
All right, so plotted my points. Negative 2, 4. Negative 2, 4. Negative 1, 1. Goose egg, goose egg. Zeros. 1, 1. Two,
Mickey
four.
Mouse. I see the nose and the eyes.
That's not Mickey Mouse.
Function?
Maybe it's just your face.
Function?
No.
Why?
Oh, yeah. No, but if you go vertical. Oh, just kidding.
It is a function. Why? Domain
Doesn't repeat.
does not
Oh.
repeat.
Like one word.
Repeat.
Domain does. Domain does. Domain is on this one, negative 2, negative 1. Negative 2, negative 1, 0, 1, 2. Range. What is that? 1, 2, 3, 4.
There's no.
What? Say what?
Function. Because none of them repeat.
The domain doesn't repeat, so Stephen, it's a
Function.
yeah.
Wait, but I have another question.
Finally, I have a function.
Huh?
Can you go back to this? Where would you draw the line?
Vertical line.
I'm not worried about connecting the dots.
Oh, if it doesn't do it.
No, don't worry about it. No. All right. So function names is y equals 2x plus 3 a function.
No.
Okay, let's think about what the graph looks like. Okay, what does this graph look like? Where would this cross the y-axis?
Starts at 3.
At 3. Agreed? This 3 is that 3. Agreed?
Yeah.
This is my slope. Yes?
2 over 1.
Slope. From this point, I'm going to go up 2, right 1. 2 points could 2 points make a straight line. Yes? Okay. Is this a function?
Yes, it is.
Yes, it is. If I wanted to write it in functional notation, what's the difference between this? What's the difference between this? What's the difference between this
F times X.
and this?
F times X.
Okay. So this
Oh my.
this stands for the function at x. The function at x. The function at x. The function at x. Hang on. The function at x is y.
What?
So if I were right here, what is the function happening at x? It was right there. What's the function at x right here? It's right there. What's the function at x right here? It's right there. What's the function at x right here? It's right there. What's the function at x right here? It's on the line. Okay? So, functional notation and y equals are the same thing. The function at x is f at x. F at x means the same thing as y.
Oh.
Okay? Anything more on that, folks? All right. How should I evaluate these?
Minus X.
I'll give you time. I'll give you time.
Divide by X.
I'll get you out. What should I do with this? What should I do with that all the way through?
Divide by X.
What should I do with this 2 all the way through these problems?
Oh, plug in 2.
Plug them in. I'm going to plug it in here. I'll plug it in here. I'll plug it in here. 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 That means y. Okay? So what about these? If I were to take this, this means I'm going to plug 1 in here. If I had this, this goes with this one. The G's go with that one. The F's go with this one. Okay? Your assignment, I don't have my thing with me. It's going to be, what chapter are we in?
3. We're in chapter 3.
Sons, we're already at chapter 3, guys. You shut up.
It's this one.
I didn't even say
One
that.
page, 65. 65, 66. Page 65, 66 is your homework, okay? Okay.
If it's not a functional